and welcome to today's video. We are almost in the last leg of this series of 15 questions of general aptitude for GATE 2024. And in today's video, we will be discussing a very important topic of numerical aptitude, that is permutation, combination and probability. So make sure that you read the questions carefully, give the questions a good chance, try to solve them at your end before you see the solution that is being discussed. It is not going to be very useful if you just watch the solutions in one go. Give it a try and then you can cross check the answer and the solution that we are going to be discussing. In the end, as usual, there is a practice question for you. So let us start. The first question for today's class. A decoration shop has 6 balloons of different colors and 4 identical white balloons. What is the number of ways in which at least one balloon and at least one candle can be bought? The options are 256, 24, 1024 and 252. Right? So read the question carefully and give it a good go. So there is a shop where you have got 6 balloons of different colors and you have got 4 identical white candles. So this is important here. The balloons are of different colors but the candles are all identical. Right? So what is the number of ways in which at least one balloon and at least one candle can be selected? So it's a very direct kind of a question. If you know how to solve at least one type of question from distinct items and from identical items, then you will be able to solve this question very easily, right? So for all of you who have practiced permutation combination earlier, or even if you have gone through the GATE 23 question paper for mechanical branch, then you would know that a question from this concept was asked, right, in that probability question. So the fundamental of that question is from this principle of permutation and combination. So the number of ways in which we can select 0 or more items out of n distinct items is 2 raised to the power n, is 2 raised to the power n. So when my 0 or more items from n distinct items, it is 2 raised to the power n. And if I want to select at least one item from this, at least one item from this n distinct items, then it is 2 raised to the power n minus 1. This becomes different if the items are identical. So the number of ways to select 0 or more items when we have n identical items, it is n plus 1. And the number of ways to select at least one item from n identical items is given by n. So this is the most basic concept or most basic fundamental without which you cannot solve this type of a question. You should know how to find out the number of ways of selecting at least one item from n distinct items, n identical items, 0 or more items from n distinct and n identical. Okay, so if you know this, you will be able to easily solve this question. So we have got 6 distinct balloons whereas 4 identical candles, and I want to select at least one, right? So the balloons are distinct, so number of ways to select at least one balloon from 6 distinct items, 6 distinct balloons is 2 raised to the power 6 minus 1, which is nothing but 63. And the candles are identical, so number of ways to select at least one candle from the 4 identical candles is simply going to be n, that is 4. So the required answer is going to be, remember, at least one balloon and at least one candle. So we are going to multiply the two possibilities and the answer is going to be 252, right? At least one balloon and at least one candle. So you know, if and then we multiply, and or means we will be going to be adding it. So and means we multiply and or means we are going to be adding the two cases, right? But here we have to select at least one balloon and at least one candle. So the answer is going to be 252. Very simple, very direct formula or very direct concept based question. What happens if I just change the question a little bit? That brings me to my next question. Just a little tweak to the question. How are you going to approach? Pause the video, give it a good read, give it a try. Let me know if your answer is equal to mine. A decoration shop has 6 balloons of different colors and 4 candles also of different colors, right? What is the number of ways in which at least one item can be bought from the shop? So not only the candles are also distinct in this case, but the question is also changed. The question is saying in how many ways can we select at least one item? One item. Item means it can be balloon, it can be candle also. Okay, so what is it going to be? So how are we going to solve this question? Think about it. So we have got 6 balloons which are distinct and 4 candles which are distinct, and I want to find out the number of ways in which at least one item can be selected, right? So at least one means I'm going to be thinking about the total number of selections that are possible, the total number of selections possible out of these 6 distinct balloons and 4 distinct balloons, and then I'm going to subtract the case where no selection has been made, where no selection has been made. That is how my approach should be for questions where at least one has been asked to find out. Right, so remember we have to select at least one item. That item can be balloon, that item can be candle also. So what I'll do is I will try to find out what are all the total ways in which I can select, what are all the different selections possible when I have 6 distinct balloons and 4 distinct candles, and then I'm going to subtract the case where I'm not selecting anything. Okay, so what is this total? This total is going to be nothing but 0 or more ways, right? 0 or more ways to select 6 distinct balloons. So 0 or more ways to select 6 distinct balloons, right? And 0 or more ways to select 4 distinct candles. This is the total ways that is possible. 0 or more ways to select 6 distinct balloons and 0 or more ways to select 4 different candles. This gives me the total number of selections possible. And then I'm going to subtract that case where I am selecting no balloon and no candle, because that's not acceptable. Because my question is saying what is the number of ways in which at least one item is bought. So I will remove the possibility of selecting 0 balloon or 0 candle. 0 balloon or 0 candle. And this is nothing but 2 raised to the power 10, that is 1024 minus a 1. So 1023. So the answer is going to be 1023. Is this clear? So in this case, we are not going to be considering 6, at least one balloon and at least one candle. Why? Because when I am selecting at least one balloon, I do not know how many candles are going to be selected. Because here they are saying at least one item. So it is quite possible that I am taking some balloons and I am taking some candles simultaneously. So I cannot look at them exclusively. I cannot say that okay, I will take at least one balloon and then I will take at least one candle. It is not going to be the case here because the question deals about items. So it is quite possible, say I say 2 balloons and I take 1 candle, right? Or I take 3 balloons and I take 2 candles. These type of situations are also possible. So I cannot simply multiply the number of ways in which I take at least 1 balloons and at least 1 candle. That won't work here. So instead, use the commonsensical approach that if I have to find at least one item, then what I can do is I can find a total number of selections possible and then I can subtract the case where no selection is being made. Clear? Moving on to the next question. Next question is a probability question. Simple, easy probability question. Pause the video, read the question, give it a try. So ABC is a 3-digit number where A, B and C are natural numbers. Point to note, natural numbers. What is the probability that A equal to B is greater than C? What is the probability that A is equal to B is greater than C? ABC is a 3-digit number where A, B and C are all natural numbers. Right? Fairly easy. So you need to look at all the possibilities of A, B and C. So suppose ABC is this 3-digit number, right? A, B and C. So they are saying that A should be equal to B and that should be greater than C. So first and foremost, can this be 1? Can I take 1, 1? If this is 1 and 1, then C is going to be 0 because C has to be less than A and B. But we have been told that A, B and C are natural numbers, right? So 0 value is not going to be possible. So this is one case that we cannot take. The minimum value that A and B take is going to be a 2. So if A and B are 2, then C can be 1, right? So there is one way. Let me write down number of ways here. So number of ways is going to be 1. What if this is a 3? That means I can have a 1 here, 3, 3, 1, or I can have a 2 here. 3, 3, 1 is also going to be one number possible. 3, 3, 1 is one number possible. 3, 3, 2 is another number possible, right? So 2 numbers are possible. 2 numbers are possible. What if the numbers are 4? So this can be 1, 2 or 3. This can be 1, 2 or 3. C can be 1, 2 or 3. 4, 4, 1. 4, 4, 2. 4, 4, 3. All 3 numbers are possible. So I am having 3 possibilities. Similarly, if I take 5, then this is going to be 1, 2, 3 and 4. 4 possibilities, so 4 possibilities. And this way I can go up till, right up till when? A, B, C are natural numbers. So last possibility is going to be 9, where C can be anything but from 1, 2, 3 up till 8. 1, 2, 3 up till 8. So the number of possibilities is going to be 8. So what is going to be the total number of ways possible? Total number of ways possible is nothing but 1 plus 2 plus 3 and so on up till 8. Right? So how can you find out the sum? You have a calculator, use it. Otherwise, simply this is 8 terms. So n into n plus 1 by 2. Right? So 8 into 9 by 2, that will give me this sum that is equal to 36. This is equal to 36. But this is a probability question. So this is nothing but my numerator or the favorable outcome or the event space, whatever you want to call it. What is going to be my total outcome? Total outcome means what? Simply ABC is a 3-digit number, right? ABC is a 3-digit number. ABC. A can take up anything between 1 to 9. B can take up anything from 1 to 9 and C can take up anything from 1 to 9. Remember, 0 is not possible because A, B and C are nothing but natural numbers, right? And they haven't told us that repetition is allowed, not allowed. Obviously, it is allowed because here A, B and C are equal. So the total number of ways is going to be simply 9 into 9 into 9. 9 into 9 into 9. Right? So what is the required probability? Required probability. Let's see. Required probability is going to be, this is my 36 is my favorable outcome divided by my total outcome 9 into 9 into 9. So this is equal to a 4 upon 81. Required probability is 4 upon 81. So that's all there is in this question. A very simple, very easy question. Final answer is 4 upon 81. So this is the practice question for today's lesson. This is a probability question. Very simple, very, very fundamental. All of you should get this right and give it a try. Let us know your answers in the comment section below, and after 24 hours, we'll be releasing the correct answer in the first comment of this video. Let me know if you have any queries, any doubts, any questions related to the questions that we discussed in today's class. Thank you so much for watching. I wish you the very best.